Hi, I'm Aidan O'Brien-Turner, and I'm in 7th grade. I live in Boulder, Colorado, and I go to Nevin Platte Middle School. And today I'm going to talk to you about Fibonacci. What is Fibonacci? The Fibonacci sequence is a series of numbers, goes on forever. It starts with 1, then 1, 2, 3, etc. So what is so special about this Fibonacci sequence? Well, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 would be 5, 3 plus 5 is 8, and so on. This goes on forever, and it seems like a useless series, but it is actually super useful. For example, if we take these numbers and we start with a 1 by 1 square, then a 1 by 1 square, and a 2 by 2 square, 3 by 3 square, 5 by 5, 8 by 8, 8 plus 5 would be 13 by 13. We get this pattern. You can do this forever, but basically if you connect the diagonals of the squares at curved lines, get this little spirally pattern. How is this spiral useful? Well, if you've ever been to the grocery store and picked up a cauliflower and went, hey, look, there's a little spiral on that. Or went in the forest and looked at the bottom of a pine cone, been surfing and seen that waves almost always crash in a spiral the same way. Or seen your fist and seen how perfectly it closes. That's all Fibonacci. Our fist only closes because the ratios between our segments and our fingers are perfect, so it can curl up on itself. Otherwise, we'd have to make fists like this. And Fibonacci is not only useful in nature, but also in combinations of different things. For example, if you have a bag of an infinite amount of $1 bills and an infinite amount of $2 bills, how many ways could you pull $4 out of the bag? Well, there's actually 5 ways to pull $4 out. And that is actually the 5th Fibonacci number. And if you wanted to pull $20 out, there are about 11,000 ways. But if you want to find it exactly, it is the 21st Fibonacci number. So, I think I found a formula to find numbers in the Fibonacci sequence. If we draw out our table, first term is 1, second term is 1, third term is 2, fourth term is 3, fifth term is 5, the sixth term is 8, the seventh term is 13, 8 plus 13 is 21, the 8th term. 9th term is 13 plus 21, which is 34. 10th term is 55. The 11th term is 89. I'm only going to go up to double digits now because it makes our calculations a little bit easier. The formula that I found is f of x is equal to f of x minus n times f of n minus 1 plus write that a little bit bigger, f of x minus n plus 1 times f of n. What x and n stand for is, so x would be, let's pick a number, how about the 11th term? X would be 11. F of x would be 89, because f of x is the number that 11th term corresponds to. So if we want to find the 11th term, we already know it in our table. Let's pretend we don't know it. And we can start with, say, the 7th term, which can be our n. So if we know the first 7 terms, we can find that term. Here's how. So, f of 11 is equal to f of x minus n. X is 11 minus 7. Times f of n minus 1. F of, just write it out, 7 minus 1 plus f of x minus n, so 11 minus 7 plus 1 times f of n, which is 7. Now, can turn that into f of 11 is equal to f of 11 minus 7, which is f of 4, times f of 7 minus 1, which is 6, plus f of 11 minus 7 is 4, plus 1 is 5, so f of 5 times f of 7. Let's plug in some numbers. We would get f of 11 is equal to f of 4, which is 3, times f of 6, which is 8, plus f of 5, which is 5, times f of 7, which is 13, which is 24 plus 65, which is, in fact, 89. So, there's the formula for you, and here's why it works. For example, if you want to find 21 out of 3 and 5, first you start with 1 3 and 1 5 to get 8. And then, to get the next one, you add 5. So it would be 1 3 and 2 5s is 13. And then to find 21, you have to add 8, which is an additional 1 3 and another 5. So 1 plus 1 is 2 3s, and 2 plus 1 is 3 5s. 2 and 3 to get the 21. And that just happens to be the n length away. So, with this formula, combine it with, it could be useful in so many ways. If you combine it with other formulas for computers and anything else, you could get so many new formulas. Also, say you're in a think tank with a bunch of people and you have your computer and the first 500 Fibonacci numbers, but the power goes out and you absolutely need the 957th of Fibonacci number for your calculations, but the power went out so you can't look it up. Well, one way to do it would just be to add the numbers one at a time and keep adding the numbers on your graphing calculator. But this is a much simpler, easier way. If you just plug the numbers into this formula and put this into your calculator, you can calculate it with ease in a couple of seconds. And so this could also be useful, as I said, if you combine it with computers, it could open up gateways to totally new formulas. It's useful in all places in biology, the way plants grow, the way fists are formed. It's useful in astrophysics, the way galaxies spiral around, the way a small planet spirals into a star. Also, speaking of how a small planet spirals into a star, I think there's a correlation between the Fibonacci sequence and gravity, which is what I'm going to try and figure out next. So I really love talking to you about this Fibonacci sequence and about this formula. Hope you liked my video. Thank you.